Welcome back. This part of the series of videos on renewable energy, we're going to talk about the one that most people will instantly recognise: wind. Wind is driven by the sun. Obviously, differential pressures in areas of atmosphere, warm air rises, causes vacuum, cool air rushes into it, creating wind. So all it is, it's kinetic energy. We take that kinetic energy and we turn it into kinetic rotational energy through the use of wind turbine. That's a horizontal axis wind turbine. Therefore, the blades sit and face into the wind. There are different types of wind turbine. They are actually working on a vertical sail, which doesn't actually rotate. And we also have vertical axis wind turbines. You will see these coming up more and more. They take up less room. They're not quite as efficient, but they're not as noisy, and they don't cause as much of, well, I don't see them as an eyesore. I quite like to see the wind turbines. I think they look great. And it shows our advancement into renewable technologies. It is a little marker saying we are trying. Now, we use sails, as these are, call them sails. The wind hits the sail. The sail has an angle which can be altered depending on the strength of the wind. So therefore, in a 30-knot wind, the sails will be feathered slightly, causing less drag. Therefore, the speed of the actual turbine itself will match the speed that it will turn at low wind speed. So therefore, they have an optimum rotational speed, rotational velocity that drives the generator through a gearbox. So you have basically a windmill. This is called a nacelle. That's the pylon. Inside the nacelle, there is a gearbox, a braking system. Now, there must be a braking system in there. I'm sure people have seen on YouTube when a wind turbine goes into runway, braking system fails, they burn. So there must be some form of braking system on there. There will be servo motors that actually alter the pitch of the blades in the wind to create a greater or lesser rotational velocity. Behind the gearbox, there will be a shaft onto a generator. And all that does is either turn magnets in a coil of wire or a coil of wire inside magnets. Basically, the relationship between electromagnetism creates a electrical charge to flow. This is then passed back to the mainland because most wind farms now are offshore. The reason behind that is they are less obtrusive, they're less of an eyesore. We've all seen it. I don't want a wind farm in my backyard. Pure and simple, so they said, I'll tell you what, we'll put them offshore, which is a good thing because you get a constant breeze, either onshore or offshore. It depends whether it's the night or the day. Again, it's differentials in pressure caused by the warming of the atmosphere, the land and the sea by the sun. So in effect, we are still harnessing the sun's power because most of the power we get in renewable technologies is from the sun. Photons warm things up. When you warm things up, you get a differential of pressure. Photons also act on electrons to do certain things, which we'll come on to later in another video. But the sun warms the air rises, as I said before, it rushes in and turns the blades. Rotational energy is then turned into electrical energy by electromagnetism, the effect we have between electricity and magnetism, again, as I said before. Now, the growth rate of wind farms at this moment in time is phenomenal. It is a massive, massive industry. It is growing, especially where we belong on the East Coast. Grimsby, Hull, absolutely massive. Even to the point where there are new buildings, new factories, ships to service them. It's not just the wind turbines, it's the servicing of the wind turbines and all the other ancillary businesses that are needed to service it. So not only are we creating jobs, we're creating a good, strong economy, a good, strong system for people to come to our university, to our college, to your colleges, learn about renewable technologies. It is a growth industry. It is somewhere we need to go.